Now I want to take a little look at the speed of creating those new species. How often do they show up? How long does this process take to go from one species to a new species? And there's two different theories that you should be aware of. Neither one of these is necessarily correct or incorrect. They're just two different ways that this could have happened, and that's based on our understanding and on fossil evidence and all sorts of things. The first one is gradualism. And gradualism is a bunch of slow, gradual changes that eventually lead to something new. So in your diagram, this is shown as a kind of a light orange bird, and the two populations gradually, one becoming more and more yellow and one becoming more and more orange. That's a gradual change. So if we use my shapes again, gradualism might say, well, this group has split, and this group is going to become more and more kind of spiky, gradually getting more and more and more different. And maybe this other group went the other way. It's becoming more and more rounded until eventually it's not even really kind of rectangular anymore. Maybe it's just turned into a circle. So that's gradualism. It's just a really slow, gradual change that happens, and that could happen particularly with natural selection. This could occur if a trait was beginning to become more favored as maybe a slow change in the environment or the food available. This kind of a gradual change may happen, and eventually they're totally different now. The other theory is called punctuated equilibrium, and that basically says that evolution is a slow process, but there have been moments of rapid change. Now, when I say rapid, I'm not talking the rapid you and I would normally think of. When we think rapid change in like evolutionary time frames, we're thinking, well, a change that happened in like 100,000 years. That's geologically in the history of our Earth, that's pretty rapid. So maybe not like boom, suddenly changed, but not maybe a slow gradual. It's just something that happened. These might happen because of really dramatic changes or sudden events that happened that had a really dramatic change in a population. So let's say you start with our squares, and along the way, let's say that set of squares got separated into a couple of different populations. So now I've got a population of, we'll just start by not changing them, squares in these three locations. Punctuated equilibrium would say that, well, let's say something in this first population here at the top, let's say they were growing on an island, and excuse me, let's say the food changed. A storm came through and wiped out their food supply, and there was only a certain amount of food that was left that they could survive on, but only a few of them could access it. So maybe there was a mutation that occurred, or well, actually let's stick with the food example. Let's say that only the ones that had a weird mutation, they're the only ones that survived. So before this, maybe the triangles were a very small group in that population. They weren't very favored. It was probably going to be a trait that maybe didn't even get passed on very far, but died off. But because of the changing conditions, maybe boom, suddenly, whoa, huge advantage for the triangles, and the squares on that island kind of peter out or even disappear, go extinct, or at least on that area. That's one way this could happen, a sudden dramatic change in the environment. The weather changes, I shouldn't say weather, the climate, like long-term temperature changes. An asteroid hits the Earth, things like that. Another one could be just a really dramatic mutation. And sometimes a mutation is a really small thing, but sometimes it can be just boom, suddenly this thing appeared. And it all depends on where in the genes it happens. You don't need to understand why. But some genes, even a really slight change, can be a massive difference in how that thing looks, or how it behaves, or how its body runs. So let's say there's a sudden mutation that occurs in this group, and this group is just very dramatically now has a new trait that shows up. And again, maybe that gives it an advantage, maybe it, whether that's survival or reproductive, but that trait shows up. And let's say this group, nothing really happens. This is that punctuated equilibrium. There's a moment, boom, right there where something happened. There's a moment, boom, right there where something happened, whether it's a mutation, whether it's environmental or whatever, but sudden changes that led to some more dramatic changes. In reality, gradualism and punctuated equilibrium are probably both kind of occurring, and you could probably find examples in the fossil record and in certain species that you could say, look, here's an example of where we've got these gradual changes in fossils from here to here. Or maybe there's other ones where like, no, we had this thing, and then that thing was gone, and now we have this thing. And it's not a gradual change, it's like a sudden, all of a sudden this thing is different. That would be more of a punctuated equilibrium. So make sure you just understand both of those theories a little bit and how that might look as a species changes. The next one I want to talk about is the time scale. So if you go to the next page in your notes, there's a picture there, and I don't have the exact picture here, but I do have another one that I want to show you. This will come up here. Yeah, just like that. Okay, so this is a similar picture to the one in your notes, but what it's showing is the number of mass extinctions that have happened on our planet. So starting on the left at about 540 million years ago, and the one I gave you in your notes goes back even farther, but you'll see that the diversity, the number of species was widening, right? There was new species showing up until eventually 445 million years ago, boom, 50% of all animal species on the planet gone. We don't know why necessarily, but for whatever reason, after 445 million years ago, we don't find those fossils anymore. They're just gone. And then for the next, 445 to 360 million years ago, life seems like it was pretty good, and there was growing and growing and growing again, and then boom, 30% of animal families gone. Then again, they start to show up again. 250 million years ago, a massive extinction. 60% of all species on the planet, as far as we can tell, gone. But the ones that survived reproduced fairly rapidly until, again, boom, 35% of the population, again, just didn't seem to pass that point. Changing in conditions, natural disasters, we don't know, but they're gone. The one you're probably most familiar with is this one right here. At the end of the Cretaceous period, 65 million years ago, there was one of the most recent mass extinctions. It is the most recent mass extinction that we've had, and that's where we lost the dinosaurs. So from 200 million years ago to 65 million years ago, the number of species of dinosaurs and other insects and plants and things was widening and widening and widening. And then something happened 65 million years ago where 50% of all of those species are just gone, including all of the dinosaurs. Now, we have some pretty good evidence that tells us that the thing that caused this one was an asteroid hitting the Earth. If you go back into the rocks, you can find basically the same layer of debris and superheated vaporized rock particles, basically, but we can find that layer all over the entire planet. And so the only thing that would make sense to have coated the entire planet in this layer of stuff, and the heat necessarily to vaporize that much rock, because the rock isn't like jagged bits of rock. They're like smooth and round, like super heated particles of rock and debris. We found them all over the place. In fact, scientists think they may have found the crater where that asteroid would have hit in a little peninsula off of Mexico. If you want to look it up, really cool stuff to figure out how they figured that out. But But that's what we think happened, that there was a natural disaster, this massive asteroid smashed into the Earth with basically the energy of 100 million atomic bombs. And that much energy would have vaporized anything close to it. But it also would have thrown so much dust and stuff into the air that it probably would have blocked out the sun and changed the climate of the planet for a fairly extended period of time. And so species like dinosaurs that maybe couldn't adapt to that kind of a temperature change, or the loss of their food, or whatever else happened as a result of that, went extinct. Species that had adapted, like things that were the mammals, for example, that could keep warm, or maybe even if you watched one of the other videos I gave you of the dinosaurs that had begun to develop feathers, had a little more insulation, and so maybe they survived that change to eventually turn into the birds and the things that we have now. So these are some examples of some just massive events that would have had a dramatic and sudden change, remember, geologically speaking, sudden change on the life on our planet, where just a bunch of them are gone, and whatever's left now starts to refill those niches, those gaps that are left in the planet, to fill those holes until, and you can see here, 540 million years worth of change on our planet has led us from things like little trilobites and those weird things that I showed you, fossils in the Burgess Shale, those weird pictures, from species back there, 300, 400, 500 million years ago, that are all basically gone, to the diversity of life that we enjoy now. And it's all just those little natural selection changes, nothing dramatic, but just little changes over time in some isolated populations. And over 540 million years, that's enough time that even those little changes could have led from those forms of life to all the different forms of life that we see now. So that's it. That's the whole thing. It's just little changes in species, natural selection acting on that variation or those little changes, and eventually leading us to, over long periods of time, to new species. So hopefully that makes sense, but I know that this is kind of a difficult concept for some people to kind of wrap their heads around. So if you're struggling with this at all, or if you have any questions, don't be afraid to send me a message or comment on the class page, and I'll try to answer any questions that you have best I can. So hopefully this helps.